Okay, welcome to this problem explanation. We are going to try to do this problem. We want to solve polynomial inequality and give our answer in interval notation of x to the fourth is greater than 7x cubed minus 15x squared plus 9x. All right, anytime you have a polynomial inequality, what you want to do is you want to get it in the form of some polynomial is greater than 0, or some polynomial p of x is less than 0, or greater than or equal to 0, or less than or equal to 0. All right, but the idea is we want to get 0 on one side and everything else, every other term on the other side of the inequality. Okay? So in this case, if we look down here, x to the fourth is the biggest power of x. Okay? So therefore, what we want to do is we want to get everything on one side. I could just subtract x to the fourth from both sides, but when I do these problems, I tend to like to have my biggest power of x be positive. So I'm going to pull everything over to the left, all right? So I'm going to subtract 7x cubed from both sides. I'm going to add 15x squared to both sides and subtract 9x from both sides. And so that's going to give us x to the fourth minus 7x cubed plus 15x squared minus 9x is greater than 0. All right, so that was the first step that we want to do. The next thing that we want to do is to try to find the zeros. All right, so now we want to solve this polynomial is equal to 0 to find the zeros, okay? All right, so the first thing that I see that I can do here is I can factor an x out of every term, right? Okay, so far so good. Okay, so now basically what I want to do is, so let's remember this, because I'm gonna have to erase my screen, so I'm gonna come back to this. So this is where we're at now. Okay, so let's remember that. I'll come back to it. Okay. So what now I want to work on is, let's look at this polynomial right here, this x cubed minus 7x squared and so on in the parentheses. Let's see if we can find the zeros of this. All right. So all right, so we want to do that. So basically the rational zeros theorem says, so whenever you have we'll say okay, sorry about that. Let's back up a little bit here. I realized I have the book, so why don't I just show you the book, right? All right, so this is on page, let's see. Well, it's in section 3.3, page 269 here. If you go down here, the rational zeros theorem, all right? It says, suppose that our function, this polynomial, looks like this, all right? A sub n x to the n down to a sub 0. Then, and the degree is n, so n is the biggest power of x, and all of these are integers, all right? Then if r is a rational 0, then it is of the form p divided by q, where p is a factor of a sub 0 and q is a factor of a sub n. All right, so let's go back to our problem here. So here, our rational zeros are going to be of the form p divided by q, where p is a factor of the coefficient of the biggest power of x. So in this case, the coefficient of the biggest power of x is 1. Okay? Because it's just a 1x cubed. All right? And, whoops, q then is going to be a factor of 9. Right? That's our constant term here. All right, so And I messed up, didn't I? Let's see, P is a factor of a sub 0. Sorry about that. I knew I messed up. P is a factor of a sub 0. Q is a factor of a sub n. So I have them backwards here. So let's go back to my problem and erase that. Fix this. So P is a factor of a sub 0, which is 9 there. And Q is a factor of a sub 1, which is a sub 3, which is 1. All right, so there we go. So therefore, P could be plus or minus 1, plus or minus 3, or plus or minus 9. All right, and Q could be plus or minus 1, but we don't need to worry about plus or minus for Q, just for the P's. So our possible rational zeros are going to be 1 divided by 1, negative 1 divided by 1, 3 divided by 1, negative 3 divided by 1, 9 divided by 1, or negative 9 divided by 1. Okay? So those are the only possibilities for a rational number that is a solution to this equation. Okay? So basically, there are 1, 2, 3, 4, 5, 6 numbers we have to check, although we can actually stop if we get one. All right, and this one, it's going to happen pretty fast. So let's check these rational numbers. So to check them, you just plug them into the equation, all right, and see if it gives you a true statement. All right, so let's check x equals 1 divided by 1. So we get 1 cubed minus 7 times 1 squared plus 15 times 1 minus 9 equals 0. So this is going to be 1 minus 7 plus 15 minus 9 equals 0. Hey, how about that? It worked out. The very first one we checked. All right. So, because 1 minus 7 is negative 6, plus 15 is 9, minus 9 is 0. So we get a true statement. So therefore, x equals 1 is a solution. It is a rational 0. All right. So we're doing good. We have 1, and really that's all we need in this problem. So if we do that, so now let's go back. Let me clear this off and then start over. So now what do we know? We have x cubed minus 7x squared plus 15x minus 9 equals 0. We know that x equals 1 is a solution. Okay, therefore, what does that mean? Well, one of the properties of a solution to a polynomial equation like this means that x minus that number is a factor. Okay, so that means that we can take our original polynomial and we can write it as x minus 1 times some other polynomial. Okay? So what we want to do then is find this some other polynomial. And if you notice, this is going to go back to, a few minutes ago to helping us solve that inequality. Okay? So let me bring that inequality back up. All right, so there it is. Okay, so, we're going to go back to solving this, but we need to figure out what this other polynomial is first. So what we want to do is we want to divide this x cubed polynomial divided by x minus 1. Okay, so we want to take x cubed minus 7x squared plus 15x minus 9 divided by x minus 1. And we should get a polynomial back. All right, so if we do long division on this, let's do long division. To do that, I can just do this, erase this, and we'll write it like this. So we have x cubed minus 7x squared plus 15x minus 9 divided by x minus 1. So the idea here is, what we want to do is we want to take the first term in here inside the divided by sign and the first term out here and see what we need to multiply this term out here to equal this. So what do we have to multiply x by to get x cubed? And the answer to that is x squared, right? So we put our x squared up there. Then we're going to take this x squared times all of these numbers here and write them underneath the appropriate terms here. So x squared times x is x cubed. X squared times -1 is minus x squared. All right. Then we subtract this. Now you have to be very careful when you're doing the subtraction. We're subtracting this whole thing, so you have to distribute the minus sign through. Okay. So when we do the subtraction here, we have a negative 7x squared here and a minus negative x squared. So that's negative 7x squared, and this would be plus x squared. So altogether, that gives us a minus 6x squared. Okay? And then x cubed minus x cubed is 0. We don't have to write 0. All right. So then we bring down the next number. So the next number is plus 15x, or the next term, excuse me. And so once again, we compare this x here and this negative 6x squared. I have to multiply x by negative 6x in order for those to match up. So then I'm going to take negative 6x times this whole thing. So negative 6x times x is negative 6x squared. Negative 6x times -1 is plus 6x. And then we're going to, again, subtract this. All right, so 15x and then minus 6x, so don't forget to distribute the minus sign, is going to be 9x. And then negative 6x squared minus negative 6x squared is negative 6x squared plus 6x squared is 0. And then we pull down the minus 9. Okay? And so now we look here, we have an x out here, and we have a 9x here, so we have to multiply this by 9. And that gives us 9x minus 9 here. And if we subtract it, we get 0. Sorry, couldn't squeeze it in very well down there. But there we go. So we get x squared minus 6x plus 9. All right. So long story short is that we can now write x cubed, minus 7x squared plus 15x minus 9 as x minus 1 times x squared minus 6x plus 9. Okay, so let's go back to the problem that I had circled several minutes ago. So the problem we want to solve is this. We had x times x cubed minus 7x squared plus 15x minus 9 is greater than 0, right? So now what we've just shown is that this stuff is equal to x minus 1 times x squared minus 6x plus 9 is greater than 0. And then, so to find the zeros of this, we can either use the quadratic formula, which is fine, or we can factor it. Let's just go ahead. This one factors nicely. It's x minus 3 quantity squared is greater than 0. All right, so here we go. We have it completely factored. The zeros now of this, the zeros are x equals 0, x equals 1, and x equals 3. All right, so what we do is we use those zeros and we break up the real numbers into intervals using those zeros. So we go from negative infinity to the smallest one of those, which is 0. Then we go from that one to the next one. The next one is 1. Then we go from that one to the next one, which is 3. Then we go from that one to the next one. There is no next one, so we go all the way to infinity. All right, so we have 3 zeros. It gives us 4 intervals. So what we want to do now is pick a test number from each interval. Don't know what happened there, sorry. Okay, test number. So pick any number you want that's in this interval. Now this is an open interval, so we cannot pick an endpoint. But it makes sense to pick a small integer value. So -1 is between -infinity and 0. 1/2, it's not an integer, but there are no integers between 0 and 1, so we'll pick 1/2. Between 1 and 3, we could pick 2, and between 3 and infinity, we can pick 4. All right? Now what we do is we plug in this test number into this equation right here, okay? So if I plug in -1, this is -1 times -2 times -4 squared. Well, notice anytime I square a number, I get a positive, right? And this is going to be a negative times a positive. So that gives me a positive, okay? So that means that this equation here is greater than 0 on this whole interval from -infinity to 0. All right, if we plug in 1/2, 1/2 here is positive, 1/2 minus 1 is negative, and then 1/2 minus 3 squared is positive, because again, it's some number squared, so it's positive. So we have a positive times negative times positive. The result of that is a negative number. Okay? If we plug in 2, we get 2, positive 2 times positive 1 times something squared, which is positive. So a positive times positive times positive is positive. And if we plug in 4, same thing. We have a positive times positive times positive. So that's positive. All right. So our final answer is I'll write it this way. Save myself a little bit of trouble. I've already written some of it. Okay. So we can conclude then that x to the fourth is greater than 7x cubed minus 15x squared plus 9x on the intervals, okay, from -infinity to 0, and from 1 to 3, and from 3 to infinity. All right, so you may be asking, well, this is from 1 to 3 and this is 3 to infinity. Why can't I just say from 1 to infinity, right? Well, the answer is it does not include 3. 3 is not a solution because 3 will actually, if you go plug in 3 into this equation, will give you 0. Actually, what would that be? 81. 81 is greater than 81. Well, that's not true. So 3 is not a solution, but every other thing is, okay? So since this is greater, if this were a greater than or equal to here, we could just go from 1 to infinity, but it's not. So we have to leave it like this, all right? All right, so that's this problem. Thank you and good luck.